and the testing department has a maximum of 360 hours available. Amina needs to manufacture at least 60 Matata cell phones each week. The profit per Akuna cell phone is 200 Rand and 250 Rand per Matata cell phone. Question 1. Represent the information as a set of constraints. 2. Represent these constraints on a graph. 3. Find the feasible region. 4. Find the objective profit function in the form P is equal to. And 5. Use a search line to find the maximum profit. We're going to start by saying let x equal Akuna and y equal Matata. Alright, let's look at the information that we do have and work from there. The first bit of information that we have says that each Akuna cell phone requires 10 man-hours to manufacture, and each Matata cell phone requires 8 man-hours. So each Akuna, each X requires 10 hours plus 8 hours for Matata. But in the third line, you'll notice that they say the manufacturing department has a maximum of 800 hours. That means that 10 hours for Akuna plus 8 hours for each Matata must be less than or equal to 800. The second bit of information we have is that each Akuna requires 3 hours in the testing department, each Matata requires 4 hours in the testing department, and we have a maximum amount of 360 hours available. That's the second inequality. The third bit of information that they give us is that the factory needs to manufacture at least 60 of the Matata models each week. That means that y must be greater than or equal to 60. And that's the third inequality we have. We don't need any more information. We can sketch our graphs from this. Moving from this onto our graph, the first bit of information, 10x plus 8y is less than or equal to 800. If x is equal to 0, it means that 8y is equal to 800, which means that y is equal to 800 over 8, which is 100. So that's the first point. I'm going to sketch it in a different color. That's the first point. The second point of that straight line is when y is equal to 100, that lies on the x-axis. It means that 10x is equal to 800, which means that x is equal to 80. 800 divided by 10. Don't put your point in of all of them first and then sketch it. Please sketch it one graph at a time. I have seen students confuse themselves. Alright, that's the first one. The second one, 3x plus 4y equal to 360. If x is equal to 0, that's going to be my y-intercept. 4y is equal to 360, which means that y is equal to 90. If y is equal to 0, that's my x-intercept. 3x is equal to 360, which means that x is equal to 120. 360 divided by 3 is 120. That will give me my second graph, or my second straight line. My third straight line is that y is greater than or equal to 60. that's just a horizontal line running at y is equal to 60. Alright, now we need to find our feasible region. Firstly, we know that it's underneath the first equation line. It's underneath that line. Right? So it's basically wherever my ruler is not. It's underneath my ruler. Second one says that it's underneath that other equation, which is over there. So it's underneath that one, and it's underneath that one, which rules out that top piece because that's above that graph, and it rules out that little piece because again that is above the graph. And that means that we are either working in this piece over here or this piece over here. Y is greater than or equal to 60. That confines us to this region over here, which I'm going to shade in black. Might not be such a good idea, but that gives us that region over there. Now notice this one could have point A, B, or point C. That's that point, and that point, which could all be the maximum points. So this is a fun set of equations to work with. We are now going to look at the maximum profit, or rather first we're going to start by looking at the objective profit function. They told us that profit on one akuna is 200 Rand. That means that our profit is given by 200x plus 250 Rand on each matata, which is 250y. I'm going to now get this in the form y is equal to mx plus c so that I can get a search line. That means that 250y is equal to negative 200x plus p. Get rid of the 250 on that side, divide it by 250 over here, which means that our gradient is negative 200 over 250 or negative 20 over 25. Easy to do. On this graph that I have, negative 20 over 25, I'm just going to go to 20 over 25, which is going to be there, and that's our objective function. That's our search line, or one of the many search lines we can have. I'm then going to take that and I'm just going to shift it up, and let's see where it intersects. It touches point C. The only problem though is it goes straight into our feasible region, and the same thing will happen with A. It will touch it, but it will go into our feasible region. Problem with that is that doesn't give us our maximum point. But if I keep that gradient constant, hopefully keep my hand steady, notice when I get to that point, my search line will touch point B, but it won't go into the feasible region. That means that point B is my maximum point, or my maximum profit function. The coordinates of B, do we have our x and y values? We don't. All we have in order to get those is the information that 10x plus 8y is equal to 800, and 3x plus 4y is equal to 360. This is one of those we are going to have to solve simultaneously. Start by dividing that top equation by 2, which means that that's going to give us 5x plus 4y is equal to 400. That means that here of 400 is equal, 4y is equal to 400 minus 5x, and here of 4y is equal to 360 minus 3x. That means that 400 minus 5x is equal to 360 minus 3x. Take the 3x across, so we have minus 5x plus 3x is minus 2x is equal to 360 minus 400, which is negative 40. That means that x is equal to negative 40 divided by negative 2, which is positive 20. So the x value of b is positive 20. The y value will be given by 20 times 5 is 100. 400 minus 100 is equal to 300. Divided by 4 is 75. That means that the coordinates of b are x is equal to 20 and y is equal to 75. If I substitute that in to work out my maximum profit, x is equal to 20, y is equal to 75. That's going to give me an answer of 20 times 200 is going to be 4,000 plus 250 multiplied by 75, which I'm going to have to work out on a calculator. 250 multiplied by 75 is equal to 18,750. That means that my maximum profit is going to be given by 22,750 Rand. Now let us look at what would happen to our optimal solution if our profit function were to change slightly. We are then asked, if the profit function for the factory is given by 180x plus 240y, would there be any difference in the optimal solution? Well, let's have a look at that. Let's turn this again. Let's look for the search line. I'm going to do this in blue. 240y is going to equal negative 180x plus p. That means that y is equal to negative 180 over 240 plus p over 240. That means that our gradient is negative 180 over 240, which is the same as negative 18 over 24, which is the same as negative 3 over 4. Or negative 30 over 40. The reason I did that is so that I can get it easily from here. Negative 30 over 40 is given by that. If I move that search line up, again notice at C it's going to cut into the graph. At A it's going to cut in. At B it's going to touch, but it's not going to cut into the graph. It's still going to just touch the graph. Slightly different gradient from the previous profit maximizing function, but still it works. I'm just checking it again using the point negative, using the gradient 90 over 120. Yes, that holds true. That means that point B is still our optimal solution irrespective. Our profit will be different though, but it will still be the maximum profit at point B. And that brings us to the end of the linear programming tutorial. This is a very practical section of mathematics and an easy section. I hope that you enjoyed it and look forward to seeing you in the next tutorial. Please go through the exercise that I left for you in the workbook before progressing on with any new tutorials.